Swayam Prabha. Digital India. Educated India.
So, last class I have discussed about the various relationship proposed to determine the ground motion parameters. Now, today's class I will discuss few more relationship for few other parameters, and then I will solve few numerical problems. Now, first other parameters, we have these two other parameters, that one is the RMS acceleration, the root mean square acceleration. What is the uniqueness of this parameter is that this one single parameter, it includes the effects of amplitude and the frequency content. It's both. It is not significantly influenced by the high frequency acceleration. It is influenced by the duration of strong motion. So, duration of strong motion is influenced by this TD value. So, that is why how you are defining that the duration of motion, based on that this value is also is influenced. So, this is the how to estimate this RMS acceleration, that Hanks and McGuire 1981, they proposed one relationship by which we can estimate that RMS acceleration. So, they proposed that relationship based on the data from California earthquake of local magnitude, Richter local magnitude ML 427, and developed attenuation relationship is for hypocentral distance between 10 kilometer to 100 kilometer. Okay. So, here you know that Fc is the corner frequency, Fx is the cutoff frequency, and R is the distance in kilometer. So, this is the same as Fc, Fx, R you know, and Fc is the corner frequency, and you know how to get the corner frequency and the cutoff frequency. So, I have already discussed how to get the corner frequency and cutoff frequency in my previous lectures. So, from there you will get the cutoff frequency and the corner frequency, and then finally you will get the RMS acceleration. But another relationship also been proposed, that is proposed in 1985. That proposed relationship based on 83 strong motion data from 18 different earthquakes with moment magnitude greater than 5. The other condition used for the database are, the R should be less than 100 kilometer, rupture depth was less than 300 kilometer, and soil thickness is greater than 100 meter. 10 meter. So, these are the conditions of the database. What are those conditions? That moment magnitude greater than 5, then the R less than 100 kilometer, rupture depth less than 30 kilometer, and thickness of soil is greater than 10 meter. So, this is the relationship where R is the closest distance from rupture to fault, and that is in kilometer. So, that is more or less same for all the relationship. And MW is the moment magnitude. Okay, this is log 10. Now, another parameter is the areas intensity. So, IA, it is obtained by integration over the entire duration of earthquake rather than over the duration of strong motion, ground motion. So, I have discussed what is the strong ground motion. So, and previous parameters that was based on strong ground motion duration. Okay, but this parameter is entire earthquake. it is integration over the entire duration of earthquake. So that's why how you are defining the strong ground motion, that will not influence this parameter, because it is obtained by integration over the entire duration of earthquake. So how to estimate this parameter? So based on the database of California earthquake, Campbell and Duke 1974 proposed the relationship for area's intensity within 50 to 110 kilometer distance of magnitude 4.5 to 8 event. Okay. So that this is the relationship for unit is meter per second, where R is the distance from the center of energy. So R and S is the for different rock or the soil. So for basement rock, it is, this is the expression 0.057 r to the power 0.46. For different rock and the soil, you will get the S value from this table, and then if you put this S value here, if you know the R value, then I will get the IA in terms of meter per second. Okay. So now I will discuss about the few examples, and then I will show you how we can use this relationship as well as some response that I have already discussed. The first one that I will discuss, that I have discussed of the Fourier series. Now how to estimate the coefficient for Fourier series, so that I will discuss my first example. So that is the example for Fourier series. Okay. Or you should say that if we have a function, so Fourier series, what I have written in trigonometric form, that if we have a variable xt, that is variable, then that will be equal to a0 plus summation of n equal to 1 to the power infinity, then an cos omega nt plus bn sin omega nt, that I have discussed. Then a0, how I will get the a0? A0 is equal to 1 by tf 0 to tf, that is xt dt. Okay. So this is basically the average value of xt over the entire tf region from 0 to tf. So this is the average value of xt over t equal to 0 to t equal to tf, and your an, that is equal to 2 by tf 0 to tf xt cos omega nt dt, and bn was, again the bn expression was 2 by tf 0 to tf your xt, sorry, this will be sine, this will be sine omega nt dt. Now suppose if I consider one function or the variable, and this side also the same thing. Okay, so this is the variable. So here this is your xt and this is your t, and this one is say a0 and this one will be minus a0. So that means this is your a0 and this one is also a0. This is plus a0, this is minus a0. In this variable I want to get the Fourier, for this function I want to get the Fourier series, and I want to get the what would be the coefficient of Fourier series. So the condition is that your xt that is equal to a0 if your t is, this is your tf by 4. So this is basically your, this is this value, this is, you can write into t or I should write tf. Okay, so if this is your, this is your tf, up to this value is tf, so that means this one is tf by 4. Okay, this one is tf by 4. So I can write that from that means if we start from 0, so that means if we start from 0, so 0 to, if t is equal to tf by 4, so I mean 0 to tf by 4, up to this is plus a0, so this will be plus a0. Okay, after that it will come down, so that means I will write that from here it will be, if your t is equal to tf by 4 to tf by 4 to, this is tf, so this is tf by 2, so this will be, this point will be 3 by 4 tf. How I am getting that? So actually this point is nothing but your tf by 2 plus tf by 4. So this will be, this is tf by 2, this portion from here to here it is tf by 2. So that means, and from here to here it is tf by 4. So if I get, this will be your 3 tf by 4. So this point will be 3 tf by 4. Again this will be tf by 4 from here to here. So this will be tf. Okay. So that means here I can write, if this is equal to 3 tf by 4. So that means from here to here, tf by 4 to 3 tf by 4, it will be minus a0, and again it will be plus a0 if I write that tf by 4 to tf. Okay, so this is the function. Okay, if we have this type of function, then the, what will be the a0 value? A0 value is the average over these, it is written average of this xt over t equal to 0 to tf, and you can see if I take the average it will be 0. The function is like that, if I take the average from 0 to 2f, this average value is equal to 0. So a0 will be 0. And what about the an? An will be 2 by tf, then this will be your, if I divide it into integration 0 to tf by 4, then it will be a0, xt will be a0, xt will be a0, and here this will be cos omega n t, then plus Tf by 4 to 3 Tf by 4. So this will be minus A0 into cos omega nt plus 3 Tf by 4 to Tf. This will be again plus cos omega t. So this is my integration, because I have divided into 3 parts, because the function is in such a way that you divide it into 3 parts. So I will get this is plus, minus, then again it is plus. Now if I do the integration, what will happen? If I do the integration, so this will be all A0 I take outside, 2 A0 divided by Tf, then this omega n, now in place of omega n I am writing 1, because I am taking your n is equal to 1. First case, so that means it will be A1. Okay, so now I am taking it is 1. So now if I take 1, this will be this omega n, this integration cos omega t. So it will be 1 by omega 1. Now it is 1. So now if I take this value, then this will be sin omega 1 t. The limit is 0 to Tf by 4. Then again plus, this is your minus. So this will be minus again sin omega 1 t. The limit will be Tf by 4 to 3 Tf by 4, then plus again sin omega 1 t. Limit will be 3 Tf by 4 to Tf. Okay, so I can give this limit. Now if I put this limit, then what will happen? And if I put this limit, and then so this will be my A1, that will be equal to 2A0 divided by Tf omega 1, because I am now taking omega 1. So this will be sin omega 1, Tf will be Tf by 4, then minus sin 0, then minus sin omega 1 into 3 Tf by 4. Okay, minus sin omega 1 Tf by 4, then plus sin omega 1 Tf minus sin Tf omega 1 divided by 4. Okay. So now I know that your omega 1 is equal to 2 pi by T1 or Tf. 2 pi by Tf, because omega is 2 pi by T. So now I can write, or if I can write Tf omega 1 is equal to 2 pi. Now if I put these values, so this will be 2A0 Tf by omega 1. So this will be sin 2 pi by 4 minus sin 0, that will be 0. Right now we put sin 0. Okay, minus this will be sin, this is 2 pi, this is 6 pi by 4 minus sin 2 pi by 4, okay, plus sine 2 pi minus sine 6 pi by 4. So now you can write 2a0 tf omega 1 white sine, this will be sine pi by 2. So sine pi by 2 will be 1, this will be 0, then minus, this value is minus 1, this is also plus 1, so this will be minus 1, then plus, this is sine 2 pi 0, then this will be again minus 1. Okay, so this value will be, this will be 1, 2, 3, 4. So I can write that this expression 2a0 and tf by omega 1 also I can convert by 2 pi into 4. Here I will get 4. So this is 1 plus 2 plus 1, 4. So it will be 4a0 by pi. So this will be 4a0 by pi for a1. Similarly for b1, b1 expression is 2 by tf, that I have written. So this will be 0 to tf xt, then sine omega 1t, if b1 I write, then dt. So here in place of these things, this will be all cos, because if it is the sine, if you integrate, the same thing, it is in place of cos, it is sine. So it will be cos 2 pi by 4, cos 0, like this. Now here if you put this value in terms of cos, this will be cos 2 pi by 4, that means cos pi by 2, it is 0. This will be 1, okay, this will be minus 1, again this will be 0, this will be your 0, then this will be your, this is minus 1, this will be your minus 1 and plus 1. So this will be also 0. This will be also 0. So whole term will be 0. So in this case for B1 it will be 0. Okay. So if you put, this is in place of sine, if you put cos, then this term will be 0, this will be 1, then this will be 0, this will be 0, this will be minus 1. So this will be 0. So that means only there will be 1 plus 1, 1 minus 1. So that will be also 0. Rest of the terms will be 0. So plus 1 minus 1, that will also cancel. So because your cos 0 is equal to 1, and so that means, and sine, in case of sine 2 pi, it will be cos 2 pi. So one will be plus 1, another will be minus 1, and rest of the terms will be 0. So this B1 will be 0. Okay. So I can write that my A0 will be equal to 0, A1 will be equal to 4A0 by 4, pi. So this will be pi, and B1 will be equal to 0. Clear? So now this is, it is if I take your n equal to 1. Now if I take n equal to 2, then what will happen? So because we know that omega n is basically your n 2 pi by tf, and you know the omega 1 is 2 pi by tf, so it will be basically n omega 1. And for previous all the terms, that is in terms of omega 1, in terms of omega 1. So if it is in terms of omega n, omega 1 into n, now if n is equal to 1, this is the expression. Now if n equal to 2, what will be the expression? If n equal to 2 you find, then it will be 4 pi by 4. 4 pi by 4 means sine pi. Sine pi, that is 0. So this is 0. So all this is 6. This will be your 2, and 12 pi by 4, that means 3 pi. So that will be also 0. So all the terms will be 0 if it is n equal to 2. So for n equal to 2, or a0 is always 0 and a1 will also be 0 now if n equal to 2, and b1 is always 0 for whatever the n value. It is 1, 2, 3, whatever, always 0. Now if I take n equal to 3, a0 will be always 0, b0, b1, now it will be b2, sorry, in place of so in case of a1 now will be a2, because your n equal to 2 now. Initially n equal to 1, that I have derived, n equal to 1. So it is a0, a1, b1. Now it is n equal to 2, so a0, a2, b2. Okay, a0, a2, b2. And now if n equal to 3, then b3 will be again 0. What will be a3? What will be a3? So now if I put now a3, if n equal to 3, then this will be 6 pi by 4. 6 pi by 4. Now it is 6 pi by 4. Then again it will be minus 1. Now initially when it is n equal to 1, this was plus 1. Plus 1. Now n equal to 2, this is 0. If n equal to 3, then n equal to 3, this will be 6 pi by 4. Because now in that case, this will be n equal to 3, 3 omega 1. This will be 3 omega 1 like this. If we can n equal to 3, it will be 3 omega 1. So all that these 3 terms will be multiplied. So this will be 6 pi by 4. 6 pi by 4 will be minus 1. So this is minus 1. This will be 0. So now if you see that, if you multiply by 3, this will be 18 pi by 4. That will be plus 1. So now if you see that if you now add these things, so that this term will be basically minus 1, this will be minus 1, this will be minus 1, this will be also minus 1. So now you can see that if n equal to 1, this is plus 4, this is 4, the total term is 4. If n equal to 2, this total term is 0. If n equal to 3, this total time will be minus 4. If you put this n equal to 3, total time will be minus 4. So that means this will be minus 4 a0 by pi. And now if n equal to 4, then that is equivalent to n equal to 2. If you go for n equal to 4, that is equivalent to n equal to 2. So that will be also 0. Now if n equal to 5, that will be equal to n equal to 1. And if n equal to 6, that will be again equivalent to n equal to 2. 7 will be equal to n equal to 3. You can see that. So finally I can write that n will be equal to plus 4 a0 by pi if n is equal to 1, 5, 9 and so on. And that will be equal to minus 4 a0 by pi if n it will be 3, 7, 11 like this. 3, 7, 11 like this, and that will be equal to 0 for all even number, n equal to even number. And bn will be always equal to 0 for all n, and a0 is equal to 0. Okay. So now finally I will write that Fourier series expression, that Fourier series that xt will be equal to 4a0 by pi, that I can take outside. Now you can see that this part is 0 always for this particular function, not always, it is for this particular function. A0 is also 0, only this part will be there, summation n equal to 1 to infinity. So there will be a cos term, okay. So now I can write this will be equal to, first, that is positive cos omega 1t. Now next one, it will be negative. For 2 equal to 0, 3 it will be negative. So this will be omega n. Now I have to convert omega n is n omega 1. I am converting omega n as n omega 1, that I will discuss. So I can get the expression. So this will be, second, for n equal to 2 it is 0. So n equal to 3 it is minus. Now it is, this will be n equal to 3 means this will be your omega 3 is basically actually your, this is 3 omega 1. 3 omega 1. Now if you integrate this will be 1 by 3 omega 1. Previously when I integrate this, it was 1 by omega 1. 1 by omega 1. So now it will be 1 by 3 omega 1. It will be 1 by 3 omega 1. So that's why it will be 1 by 3, because 1 omega 1 I have already taken care in the expression. This will be 1 by 3 and this will be cos n equal to 3 omega 1 t. Then for 4 again it is 0. For 5 it is positive 5 omega 1 t. Then 6 again it will be 0. 7 it will be negative 1 by 7 cos 7 omega 1 t. Then for 9 it will be again positive. 10 it is 0, 8 is it 0, 9 it will be again positive. Then 11 it is again negative 1 by 11 and so on. So this will be my expression of Fourier series. Okay. So this way I have already discussed that how we can get a Fourier series for a given variable or the function for a particular given function. From here I will get the Fourier spectra also. So how I will get the Fourier spectra? How will get the Fourier spectra? You know what is Fourier spectra? This is plot between Cn versus omega n. Okay. Now what is Cn? Cn you know, that is equal to an square plus bn square. And your phi is equal to tan inverse your a n by bn. That is phase. If you plot the phi n versus omega n, that will give you the phase spectra. Now here you know that if so here bn part is 0, so Cn will be root over an square. Okay. So because bn is equal to 0, here your, and if you see that Fourier spectra, that you know that I have already discussed, C0 is equal to A0, so that is equal to 0. So what I will get for C1 I will get n square. So C1 will be 4 A0 by pi. C2 will be equal to 0. Again C3 will be equal to again 4 A0 by pi. Why not minus? Because it is minus whole square. So it will become plus. So that's why, because actually C3 is, if I write this one, the C1 is basically root over A1 square, and A1 you will get from here, A1, A2, A3, all this, and C2 is equal to basically A2 square. Now A2 is equal to 0. Okay, then C3 is basically root over A3 square. A3 is minus 4 A0 by pi. So it is square, it will be positive, then it will be root, this will be the value. Okay, so this way I can write C4 is equal to 0, then C5 will be again 4 A0 by, so this there will be 3 pi, this will be 5 pi. Why 3 pi? Why 3 pi? Here if you see that, yeah, here I missed one term, that is equal to n. Why there will be n? Because as I mentioned, if I do that integration, there will be 1 by n. No? So that I missed here. Please add that, because here if I, this is 1, then it is, if it is omega 1, if I do the integration, this is 1 by omega 1. If it is 3, then it will be 1 by 3 omega 1. If it is 5, then it will be 1 by 5 omega 1. So that will be, it is 1 by n omega 1. Here it is n is equal to 1, that's why I have not written. Actually it is 1 by, after integration, because it is n into omega 1, because your sine equal, this omega n is equal to n into omega 1. So if I do the integration, it will be 1 by n omega 1. So that n you have to taken care here. So here also this will be actually 3. 1 it is 1, 2 it is 0, it will be 3. That's why when I take this value, because I have here it is, I have taken 4 A0 pi. So in this n value I have not taken into consideration when I take the common. So that's why this n will come here, 1 by 3 in case of n equal to 3, 1 by 5, 1 by 4, 1 by 7, 11, like this. So that's why it is your n term is should be there. So C1 will be n equal to 1, C2 0, C3 3 pi, C5, C6 will be equal to 0, C7 will be equal to 4, again A0 by 7 pi. Okay, and C8 equal to 0, and so on. So now if I plot this Fourier spectra, so this will be your omega, and here it will be your Cn. So that is your Fourier amplitude. So first one, C1, your, this is C0 equal to 0, C0 equal to A0 equal to 0, so this will be 0. Then the next term is this one. What is that value? This will be 4 A0 by pi. After that it will start reducing, because this is 4 A0 by pi, then 1 by third, 1 by fifth, 1 by 7. So then this is, if you say this is your 1, this is 2, this is 3, this is 4, this is 5. So 2 it will be 0, 3 it will be 1/3 of that, 4 again it will be 0, okay, 5 will be like this, 6 it will be again 0, 7 will be like this here, 8 will be 0, so like this. So this is your spectral value. So if I write in different colors, so these are the points, 0, so 4 pi, then this is 0, again 5, then 0, 3, this is 0, this is one value, this is 0. What is this value? This value will be 4 A0 by 3 pi. What is this value? This value will be 4 A0 by 5 pi, and this value is definitely 4 A0 by pi, and so on. This will be if it is 5, then there will be 1, 2, 3, or this is 0, this is 1, 2, 3, 4, 5, 6, there this is 7, 4 a0 by 7 pi, 7, this is 8, similarly again it will be 9. So these will be the variation. So these will be your Fourier spectra. Similarly, I can draw the your phase spectra also. Similarly, I can draw the phase spectra. How I can draw that? So I know that phi 0 equal to, so phi 1 will be what? Tan inverse A1 by B1. B1 is equal to 0. So this is possible if it is plus pi by 2. Because tan pi by 2, then it will be, because B is equal to 0. So this similarly phi 2 is not possible, because phi 2 is 0, because here A0 is also 0, A2 is also 0. Phi 3, it will be tan inverse A3 by B3. So here we can convert it to pi plus pi by 2. So this will be minus pi by 2. Similarly for phi 5, it will be tan inverse A5 by B5. So this will be again plus pi by 2. So this way I can get plus minus, and then if I plot just phi and the omega, I will get the phase spectra also. So this way I will get the Fourier series. From there I will get the Fourier spectra also. That I have discussed. The theory I have discussed in the previous lecture. So today I have just solved one particular case, I want to take one particular function, and then I solve, and then I get how we will get the Fourier series. So in the next class I will discuss about that how I will get the response of a particular function. Okay, I have discussed different condition for to get the response of different conditions. So next class I will solve one such problem. I will discuss, I will get the response for one particular or few such conditions. Thank you.